direction, if it will be +1, it will be -1. So again, if it is +1, it will be -1. Both will be cancelled like that. So this is about the actually yesterday topic we discussed. Right? Next, we'll see the ammonia and NF3 molecule. What happens to the ammonia and NF3 molecule? How their dipole moment looks here. Now, when you observe your NF3 and NH3, NH3 is having 4.9 dB something, 4.9 something you're having. It is having 0.8 coulombs into meter actually. Okay. So one is having 4.9, other is having 0.8 into 10 to the power -30. Now we get a doubt actually. In the both the case, nitrogen is there. Here it is nitrogen and here it is nitrogen. But with the presence of hydrogens, the dipole moment is 4.9. With the presence of fluorine, the dipole moment is what? 0.8. So how you explain this one? That is important for us, isn't it? The ammonia dipole moment, how much you're having here? 4.9 into 10 to the power of -30 coulombs into meter. NF3, 0.8 into 10 to the power -30 coulombs into meter. Now, in the case of ammonia, the orbital dipole due to lone pair is in the same direction. Now, when you observe here, lone pairs are in same direction. Where in the, isn't it? Ammonia. I will show that one in the diagram. First of all, you underline this one because in examination, if they ask what happened, you need to write these points. In ammonia, the orbital dipole, whatever the dipoles are there, which are same direction with respect to what? Lone pairs actually. I will show this one. As a result, what happened? NH bonds are having more dipole moment. Whereas in NF3, what happened here? In NF3, the orbital dipole is in the direction to the opposite of the what? The opposite here. Whenever if we get the opposite direction, what happened? They will be cancelled each other here. Therefore, what happened? It has less dipole moment here. Okay, let me see this one. For example, you observe this diagram here. Nitrogen is what? Negative character, right? Hydrogen is the positive character. Now, always will move to what? Like this direction. Moving what? Upward direction. All are moving which direction better? Upward direction. Now, nitrogen is have a lone pair. Every nitrogen will have a lone pair. So, the lone pair also will be taken upward direction. Now, if you observe all are same direction or opposite direction, when you observe this one. Yes?
The same direction.
They are moving to, see, the three hydrogens are moving toward nitrogen. When you have a lone pair, always you have to show towards lone pair actually. So all are in same direction. They are saying what happened? Same direction. You observe here what happened? They're saying what in? Same direction they are saying. See, you observe here what happened. They're in same direction. Okay. But when you consider this one, NF3, now nitrogen will have a positive character. Fluorine is more electronegative than the nitrogen. Therefore, fluorine will have more electronegativity, minus charge. So, fluorine is having more electronegative than the nitrogen. Why? Because nitrogen is which group beta? 5th A group. Fluorine is 7th A group. Higher the group number in same period, always will be higher electronegativity. Now, what I am showing here in this downward direction. All are downward direction. Correct? All are what? Downward direction. Now, the lone pairs you are having here, always lone pairs in which direction beta? Upward direction. So, 3 are downward direction. 1 is what? Upward direction. Now, if you observe these two also opposite in direction. These two also opposite direction. So, this is the reason what happened, the dipole moment what happened less in this case. So this is about the NH3 and NF3. So if they ask in examination, you have to write like this. Lone pair in ammonia, orbital dipole due to lone pair is in the same direction. Okay. In this case, what happened? In opposite direction. In opposite direction. Now, if you observe what happened, some of the molecules, if you observe here, what happened? You observe here what happened? Hydrogen. Isn't it? Can you develop any charges here? No. Therefore, 0 here. Carbon dioxide, I am writing here. Carbon dioxide, I am writing. Carbon dioxide dipole moment will be 0. It is a polar bond. It is having polar bond. See, carbon is having positive character, oxygen is having negative character, oxygen is having negative. Now we have to show in which direction? Towards oxygen, like this. Towards oxygen, like this. Now, for example, if it is having +2, this will be how? -2. The polarity of this bond, if it is +2, the polarity of this bond will be -2 because vector quantity. So you should get mu net is equal to what? 0. The net dipole moment will be 0 in this case. What I am saying, bonds are polar. The bonds are polar in this case. But the dipole moment, if you observe what happened, that will be 0 in this case. Understood here? Next, when you observe CH4 here, when you take the CH4 here, I am writing the CH4 here, carbon, hydrogen, 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 hydrogen. Now here it is a positive hydrogen, carbon will be negative. Hydrogen will be positive, hydrogen will be positive, hydrogen will be positive. Now you observe, like this the flow will be takes place. In this also, like this the flow takes place. In this also, towards the carbon the flow will be takes place like this. And towards the carbon the flow will be takes place like this. Now these two will be cancelled here and these two will be cancelled here. Okay, and this one, both will be cancelled. Both will be cancelled. And these two will be cancelled. So the net dipole moment will be what here? Net dipole will be 0. So CH4, how much you are getting here? Similarly, what happened? CCl4 also. Similarly, what? Who is that one? Who on the mic? Right. Here also same. Chlorine, chlorine, and chlorine. Now chlorine is more electronegative better. This is negative. This one will be positive. Again, negative, negative, negative. So you have to show in this direction, like this, downward direction, like this, like this. Okay. Again, here also what happened? They're cancelled with each other. Opposite directions. See, both are opposite. If it is +1, this will be minus. If it is +1, this will be -1. So the net dipole moment again, what happened here? 0. Right? In this way. But when you observe CSCl3, this part, it is not 0. Why? Because I will show this one. This will be 0. Why? What is the reason? Let me see this one. Which one? CSCl3. I am taking here CSCl3. Okay. Here I am writing what happened? Chlorine or hydrogen you take here. Hydrogen you take. Cl, Cl, and Cl. This will be negative, 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 positive. Now here positive 2, this will be negative. With respect to hydrogen, it will be negative. With respect to chlorine, it will be positive. With respect to chlorine, positive. With respect to chlorine, positive. So here it is showing downward direction. Here also downward direction, and here also downward direction. It will be on upward direction. Now you can say these will be cancelled, but see with CA, this is CH bond, upward is a CH bond, downward is what here? CCl bond. How they are cancelled with each other? If it is what happened, something what happened, +1, this will be -2 because it's CCl bond, downward side CCl bond, upward side is what? CH bond. So both are not same. No? So that is the reason it is what? +1, this will be -2. Yeah. So net dipole moment will be there, that will be 1.0. That means what I'm saying here, around the atom, the bonds, the bonding atoms must be same. See the bonding atoms here, what happens? Same. Here bonding atoms are same. Here bonding atoms are not same here. One is hydrogen, remaining are chlorines. Understood here? Now here BF3, bonding atoms are same. You got 0. But now here, why you are getting dipole moment? Because nitrogen has a lone pair. So when you have a lone pair, what happened? Definitely they can show the dipole moment. Even though you're having what? Same atoms surrounding. NH3 surrounding same atoms here. Even though it is having same atoms, because of the lone pair, it has some dipole moment. Yes. But in BF3, what happened? Even though they're having same atoms surrounding, because of absence of lone pair, here no lone pairs on the boron here. Boron does not have any lone pair here. Therefore, the dipole moment will be 0, isn't it? This is the concept you need to remember. Not much information is there in this Please you just remember these things which I have explained here. Okay. Next, we will see some Fajan's rules that we discussed today. Continuation to this one, we will see something Fajan's rules actually before this. You can also explain the geometry also that we'll see in the valence electron pair repulsions theory. Now let me see the Fajan's rule better. Fajan's rule. Now what is this Fajan's rule here? The first rule, if you observe here, this is the first rule. Only 3 rules will be there. The first rule, if you observe what happened, when you have smaller size cation and larger size of the anion, you will going to have larger covalent character. So I'm writing here, all of you please observe here. Now what I am writing, size of cation. Is it visible for you? Whatever I'm writing is visible?
Yes, sir.
Remember, this is very simple concept and very important. Size of the cation directly proportional to ionic character.
Yes, sir.
Ionic character, right? And size of the anion. Size of anion. Size of the anion directly proportional to covalent character. Correct? Right? Next. Ionic and covalent both are inversely proportional. Ionic and covalent both are what happen? Inversely proportional. Now, for example, if you have large size of cation, its covalent character will be? If you have large size of cation, its covalent character will be? Tell me. Tell me better.
So can you repeat it?
If you have large size of cation, what type of character it will be have? Ionic or covalent? When you have large size.
Sir, ionic.
Ionic, sir.
Ionic, sir.
Now tell me better here. Large size of the cation, more ionic character. Now among these, which will have more ionic character better? Which group elements better? Lithium, sodium, potassium, rubidium, cesium.
First group.
First group. So from lithium ion to cesium ion, size of the cation increases, ionic character also increases. Cesium ions are more ionic when you compare with lithium. Now lithium I can say more covalent. I can say lithium is what? More covalent because small size of cation, more ionic character. Understood this one? Everyone understood?
Yes, sir.
Yes, sir.
Next, one more example I'm writing here. F minus, anions I'm writing. Cl minus, Br minus, finally I minus. These are all anions belongs to 7th A group elements. It belongs to 17th or 7th A group elements. Now the size of anion, what happened here? Increasing here. Okay. Now which will have more covalent character?
Iodine.
Iodide is having what? More covalent character. More covalent character. And fluorine will have more ionic character. Less covalent means more ionic. Okay. Whenever if you have less covalent, it will have more ionic. Isn't it? Less ionic means what happened? More covalent character. So this first point is understood here. This is the first point actually. This thing is whatever I written here. This is the first point actually. The smaller the size of the cation and the larger the size of the anion always will be leads to covalent character here. Okay. So when you have what? Large anionic size, covalent character will be more. Small size of cation, covalent character will be more. That means simply if you write size of the cation is directly proportional to ionic, size of the anion will be directly proportional to covalent. Right? Second thing, if you observe, charge on the cation, isn't it? Or even anion always will be, isn't it? Greater, it will be what? Covalent character. What I'm writing here, simply charge. This is the second point. Charge directly proportional to covalent character. Isn't it? When you increase the charge, what happens? Covalent character also increases. So I'm taking one example here. Na plus magnesium plus 2 and what happened? Aluminium plus 3. Now tell me which is having more covalent character. What happened? Which is having more covalent character better?
Aluminium.
Now we have to see the charge here. Whichever is having more charge, that will have what? More covalent character. Therefore, covalent character what happened? Increasing here. Here what happened? Covalent character increasing. Now we have to do one thing. In your notebook, put some Fajan's rule like this. Put some Fajan's rule. Now write down this one. First point, size of the cation directly proportional to ionic character, size of the anion directly proportional to covalent character. Take these two examples. First example, second example. Next. Second point is charge is directly proportional to covalent character. Take this example here. Na plus magnesium and aluminium plus. A last one, if you observe, that will be something lengthy here. The third point. Here, what is actually happening here? The cations of is any cation which is having what? Octet configuration. When it exhibit octet configuration, they will be ionic in nature. If they are pseudo octet configuration, they will be what here? Covalent character. I will explain by taking a PowerPoint here in this case. See in a PowerPoint. Now, first of all, I'm saying writing here, the third point here. Third point, I'm writing like this. When you have inert gas configuration or octet configuration, then this will be definitely what happened? Ionic in nature. It will be definitely what happened? Ionic in nature. For example, if you have pseudo inert gas configuration, then it will be which type of character? Covalent character. This will be covalent character. Now let me see what is inert gas configuration. Having 8 electron, ns2 np6 electrons if you have, that is equal to 8 electrons if you have, then that is called what? Inert gas configuration. If for example, if you have ns2 np6 nd10, you are having 18 electrons, then it is called what? Pseudo inert gas configuration. What is pseudo inert gas configuration? ns2 np6 nd10. That means extra you are getting what? 10 electrons in the d orbital. That is called what? Pseudo inert gas configuration. Let me see this one with an example like this. I'm taking calcium plus 2. Okay, in calcium chloride, calcium will be calcium plus 2. Now calcium configuration I'm writing first of all. Calcium configuration I'm writing. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? Now this configuration is neon configuration, so you can write neon configuration, and remaining I'm writing 3s2, 3p6, 4s2, right? Now calcium plus 2 means how many electrons it should lose? How many electrons it lose?
2.
2 electrons, that too from last orbit. Valency shell is 4s2. So these electrons we are losing here. So what I'm writing here, calcium configuration will be neon configuration. This one, 1s2, 2s2, 2p6. Next, what happened? 3, instead of writing 1s2, 2s2, 2p6, you can write neon also, because neon configuration is what? 1s2, 2s2, 2p6. Now we are getting 3s2, 3p6. Now it is definitely will be ns2, np, because it is the last orbit no for now. Now it is having how many? 8 electrons. Now calcium plus 2 or calcium chloride will be which type of character beta? Which type of character it will have? Calcium plus 2.
Ionic.
Ionic character it will have. It will have ionic character, right? Next, please note down all of you, because it is not there in the textbook. You have to note down this one. Next one, if you take zinc chloride, that is nothing but zinc plus 2 configuration. Now, first of all, I will write the zinc configuration now here. Zinc configuration I am writing here. That is what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Right? 3d10. Now, in this case, what happened? I have to write zinc plus 2 now here. Now, in zinc plus 2, what is the valency shell? 4s is the valency, because it is the outermost orbit actually. So you have to remove these 2 electrons. Now, what is the configuration you are going to get? Again, this configuration will be again neon configuration. So write down the neon 3s2, 3p6, and you are getting what? 3d10. Now, this is what actually, what type of configuration you are having? ns2, np6, nd10 configuration. Nothing but you are having 18 electrons. Therefore, it is called what? Pseudo inert gas configuration. Pseudo means what? Just like inert, just like pseudo means just like a Xerox like that, isn't it? If you take a original and Xerox, both looks what happened. Both will have same matter. The matter will be same. Only the appearance will be different actually. Same like that. Pseudo means but just like what? Inert gas. Now tell me, zinc chloride will be ionic or covalent beta?
Covalent, sir.
Covalent character. So this is the third point they are saying. These are the 3 rules which is given by the Fajan's. The first rule is what actually? The charge of the cation directly proportional to ionic character. The charge of anion directly proportional to covalent character. Second one is what? Sorry, charge, not size actually. Sorry, size. The size of the cation directly proportional to ionic character. The size of the anion directly proportional to covalent character. Second point is the charge of the ion. Any ion, it may be cation or it may be anion. Any ion it may be. So in that case, what happens? Charge increases, covalent character increases. Finally, what happened? Inert gas configuration, ionic character. Pseudo inert gas configuration, covalent character. This is the thing actually they explained here. Isn't it? This is already we discussed this one. Why water is having dipole moment beta? Because of lone pair. Because oxygen is having lone pair. In the case of BF3, already we discussed here. Everything is cancelled. Therefore, it will be 0 dipole moment. And NH3 and NF3 also we discussed today only, because it here both are the lone pair and this one same direction, but here is their opposite direction. Therefore, it is having less dipole moment. Already we discussed this point. Understood? So what I am doing here, whatever I written here, these things I have written, I am saving this one here. Here only I am saving this one so that it will be useful for you. And I will send this in the form of PDF. Okay. So that you can easily understand. I am saving this one, right? And the remaining this part you have to write on your notebook. What is that one? This part. This part you write. Okay, you can watch the video again and write down this part actually. First point, second point, third point I have saved in that one. Okay. So this is about the today's class. Fajan's tools I have completed. On Monday, day after tomorrow, I will take class again at same time, 9 to 10 o'clock. 9 to 10 I will take. Vesper theory I will complete on Monday. Valency shell, electron pair, repulsions theory. So before that, what happened? By Monday, everyone should write some things actually. I will show that one. Just a minute. Everyone must complete up to what happened. Up to 4.20, because every day I'm saying this one you have to complete in the notebook actually. 4.20, 4.22 also, if possible geometry is, okay, 4.22, because today only we completed BES2, NS3, NF3. Today only we completed 4.23. Okay. So up to 4.20, 4.22, 4.23. So 4.12, 4.20, again 4.22, 4.23. These are the exercises you need to post on by Monday. Okay. I will assign a link. To that link, you have to compulsory send that one by Monday, right? So Monday, whoever not submit, I don't allow them to attend the class. By Monday 9 o'clock, before 9 o'clock only, you have to submit the notes, right? Only 47 students were there today. 47. So I'm taking the attendance. Please stay with me. Yes. Abhishek Sharma.
Yes, sir.
Abhishek, why?
Present, sir.
Abhishek, why you have to call me after that 10:30? You call me now, okay? Abhishek, why? After 10 you have to call me, right? Atya, absent. Akriti, yes. Anshu, Anuj,
Present, sir.
Anushka, Apurva, Adarv, Ayush, Balmukun,
Present, sir.
Ashif,
Sir.
Atul,
Present, sir.
Bharti,
Present, sir.
Chaitanya,
Present, sir.
Dhanashree,
Present, sir.
Jnaneshwari,
Present, sir.
Gulabi,
Present, sir.
Kalpesh,
Present, sir.
Krunal,
Present, sir.
Mayur,
Present, sir.
Ojas,
Present, sir.
Omkar PC,
Present, sir.
Samiksha,
Present, sir.
Pradhamesh,
Present, sir.
Rahul absent, Raj, Ramya absent,
sir.
Ramya absent, Riya,
Present, sir.
Rohit,
Yes, sir.
Sahil absent, Samruddhi,
Present, sir.
Shashiranjan,
Present, sir.
Sardak absent, Shashidhar,
Present, sir.
Sneha Ji,
Present, sir.
Sneha VS, Sneha VS, Sonali,
Present, sir.
Srihari, absent, Sumit AM, absent, Sumit SD,
Present, sir.
Suraj C, absent, Suraj TU,
Present, sir.
Triambak,
Present, sir.
Umesh absent, Vaishnavi N,
Present, sir.
Vaishnavi J, Vaman, Vedant,
Present, sir.
Vishal,
Present,
Present, sir.
Pallavi absent, no? Absent. Swastika,
Present, sir.
Tejaswini.
Present, sir.
I'm just reading the absentee names. Pallavi, Vaman, Vaishnavi J, Umesh, Suraj, Sumit AM, Srihari, Sneha VS, Sahil, Ramya, Rahul, Manoj, Kaushal.
Sir, Rahul is present.
Which one? Who is one?
Sir, Rahul.
अटेंडेंस लेते क्या किया तुमने?
सर नेटवर्क चला गया था.
Manoj, Kaushal, absent. These are all actually. Deepta absent.
Excuse me, sir.
Aditya also absent. Right, you can log out.
Hari was present in class, sir. He just logged
Who,
out, sir.
who beta? Srihari.
Yes, sir. He messaged me some network issue was there, so he left the meeting.
Okay, okay. Right. You can log out better.
Thank you, sir.
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 Thank you, sir.